Hello guys, welcome to Sunrise classes. So today we are starting the lectures on the probability. This session will be solely in English, and a lot of candidate who does not understand Hindi, I have made this session for them. And obviously these lectures will be in English and will be very appealing to all of you because I am going to make it as in layman language as possible. So let's start the class. According to me, you all have gone through the course design that I have provided first of all, and if you haven't gone, please must go through that, because on those basis only we will going to crack the exam. We are going to prepare for this exam, and that's why I always tell you to view the entire lectures, the complete lectures on course design and the in-depth analysis of syllabus, because without that, according to me, it will not be easy for you to go through it, because the course of ISS, whether it is for the ISS or for the RBI, is not so easy as you are thinking of. As a lot of candidates comes to me and tell me, sir, I have completed my MSc. Yes, you have completed, you may have completed, and you may have gone through suppose the very best college or university of the India, but then also this exam will be something different. This preparation will be something different than what you have been taught in your colleges or universities. So believe me, if you came here, the first thing is believe in me and believe in yourself. There are only two things that I will ask you to do: believe in me and believe in yourself. Believe in the strategy that I am putting here. This is not the strategy that I am just experimenting. This is the strategy that I have experimented with a lot of candidates, but there is no need now to have more experiments. It's experimented a strategy and it has worked well for other candidates, so it will work well with you as well. The first lesson that I will start today will be of preliminary type. That means when you start a study of a particular lecture for a particular book, the first thing that you see in your book is preface. Suppose this is something like that, but I will not say it preface, because preface or jo forward is nothing but the introductory or the in-depth analysis of the entire topic that I have already completed. And then after, what second thing that you see in any of the book, obviously this journey is also a type of book that we have to finish at the end of the year. And so the second thing that you see in your book is preliminary. That chapter 0, you can say it. A lot of authors write it chapter 0. So I am starting today chapter 0, and the name is measure theory and integration. I will not teach you integration, because integration you have already completed, and if you haven't gone through the integration as well, and if you are not good in integration, I always recommend to go through any book, whether it is of the BSc level, any BSc level, bachelor's level book of the integration and calculus, must go through that. Calculus, integration, matrix algebra, and the algebra topic you must have to go through. Otherwise it may possible that sometimes you may get confused, though don't worry. In that part also, I will be here to help you come out of that confusion, so don't worry about. But yes, do whatever I will say. Believe in me, believe in our team, and believe in yourself. None other than me and our team, and none other than you can help you apart our team. So you just have to go through the process. You just have to go through the lectures, you just have to go through the assignments and you just have to go through the homeworks that we will provide you. Practice it more and more. Attempt the test series, whatever will be on the regular basis. And then I'm sure, I'm by heart sure, deeply sure that you must crack this exam. With these efforts, just have confidence in yourself. So let's start. The first thing that I will teach you is set theory. Now you can ask me, sir, why are you going to teach me a set theory? Because I didn't came here to uh, learn the set theory. I have gone through these also in the class 8, 9, 10, 11, 12. I have gone through this. Why are you wasting my time in doing these things? You can ask me. Yes, you can. You have, I have made you free to ask me questions. Yes. So the first thing that I will say, suppose after doing this course and after having completed given the exam, you became an ISS officer. What do you do after then? What will be your work? That means what I am telling you, what I am asking for. What is your function then? What is the function of an ISS officer? What functions an ISS officer do in the system, in the government? Obviously you can say most of you know that, and you must say me, sir, an ISS officer make policy, make data driven policies. Then the next question for me will be, does each and every policy applies to each and every person? Suppose I am taking the example of GST. So does every sphere of the human activity comes in the category of GST? Though you can say that yes sir, every sphere of human activity comes in the category of GST. So I will ask you next question is, does every sphere of or every level of capital formation has the same taxation process, have the same taxation rate? Then you will say no sir. Yes, the answer of this is no sir, because the taxation process for different level of income group, for different level of wealth, has different categories, different taxation level. So yes, but when you do a policy, when we create a policy, we must take into account some of the characteristics of the population, some of the characteristics of the group of people, some of the characteristics of group of individuals on which we have to apply some of the policies. Suppose you are making GST policies for the farmers class. Suppose you are making policies, GST policy for the rich class. If it is a luxurious good, you can take 40% GST on that and no one will ask anything. But suppose some governments come and 40% GST will be applied to the wheat or barley or suppose rice. Do you tolerate that? Do you not do the civil war? Yes, you do. Because the basic amenities that needs for living, for the livelihood of a very simple guy, a very simple family, can't come under the GST. Because if those guys pays the GST, then there will be no prosperity means for the nation. So yes, whenever we make some policy, whenever we make some rules and regulations, there must be that must be applied to some category of people, some group of people which have something in common, some characteristic, some property in common. And what is the definition of set? Definition of set says a group of objects or individuals which have some property or properties in common, and that group of object, well defined group, we say well defined. So suppose I am making a policy over that someone who is drunkard or who takes wine will not be given the government job. And suppose someone of you may come and ask me, sir, I have drunk in our life one time. Sir, can you please grace on me? Huh. Then there should be a clear cut demarcation onto who will be considered as drunkard and who will not be. So this is the main meaning of well defined, that you already know. I am not making emphasis on these things, but still this is a set, na? So yes, to study the probability concept, to study the statistical inference concept, and to study any of the things, you not only work in just on one point, but you always work on a group of individuals. Suppose I ask you, what is the probability that tomorrow the sun will set in the west? You already know that sun is always setting in the west. How do you know that? How do you know that? You can say, sir, it is established, proved. It's a proven statement. How do you know that? It's a proven statement. The proof that you have seen, it's just some numerical values and some thought process. So how do you know that? We know this because we have observed it from the last of the day. Not only me have observed, our parents, grandparents, grandparents, and so they all have observed this, and that's why we say that yes, sun rises in the east and sun set in the west. That means these all are observations, and those observations are nothing but the groups of datas, isn't it? Yes, those observations are groups of datas. So we take all the decision on the basis of some datas, and those datas are nothing but group which have some property or properties in common. Suppose you have taken admission in the sunrise classes. Obviously, you may have done some research, and you have tried over different things, that whether this happens, this happens, this happens. So you may have taken all the precautionary things. And how did you do that? Because a lot of candidates from the sunrise classes have got qualified, have studied here, and have experience about what sunrise classes is. And that's why you can think these guys who have studied and got qualified, and different peoples who is related to sunrise classes, these are considered as a set whose property is that these guys have at least once studied in the sunrise classes, at least once have taken some service in the sunrise classes. So this property is common to all of them to whom you may have concerned. So these are the things that we have common in the set. So yes, we will start with the set theory, and then we'll go ahead and we'll let you know what next thing will be. Don't worry, it will be a very interesting session, though it is in English. A lot of candidate who does not understand English can request for the Hindi session as well, because Hindi session is already recorded, and yes, you can go through that session as well. But believe me, the Hindi session and English session will be something different. English session will also be joyous. Hindi session, obviously, in India, Hindi is the mother tongue, and so it's our heart and soul. English is also the second language, and I respect this language. So, first thing is, in many discussions, we have to deal with groups. In many discussions, in not many, in about all the discussions, we have to deal with the groups, or we can say aggregate of individuals. Yes, aggregate of individuals. Getting the point? And these aggregate of individuals are not so versatile. It is those aggregate of individuals which have some property or properties in common. So this is the main characteristic defining set. And so after having defined the set, I will fastly move on to the next one, and we'll try to cover the properties of the set in a very fast manner. So just start writing down, because I will not only teach you these things, I will also try to let you make notes for this, because if you haven't make the note, it will go very blurry or enchanting. So to have a clear cut understanding, must make a notes. If you do not understand anything, must request for the live doubt session. There is no issue, live mentorship session is always there, and I will be there to let you know. So let's start now. The first thing is, the first topic that I am going to teach you is concept of set theory. So first thing, I will define the set. Now, what will be the definition of set? What should be the definition of set? Right? Let's write. A group of individuals, a group of individuals with some property or properties in common. A group of individuals with some property or properties in common. With some property or properties in common is called a set. What it say? It says a group of individuals which have some property or properties, if more than properties in common, is called set. And any member and any member of the group, any member of the group is called an element or point. Is called an element or point. I will write something, but yes, most of the thing I will read out, I will uh, deliver here, and you just have to write it on your pen and paper. So is called an element or point of the set. Sometimes it is called point. I will come at the point where we will define set function and point function as well. Don't worry, all those things will be there in the major theory. So yes, I will come to there. Okay. So suppose I'm asking about all the students who is studying in Delhi University. All the students, all the statistics student who is in Delhi University, who is studying in Delhi University. So these are the sets. I'm not giving any particular example because I know everything, you know it well. So I will write it somewhat. I will, in general, we all know that a set is generally defined in the italic term and caps letter. Okay. So we always define a set by the capital letter, capital Roman letter, A, B, C, D, anything, X, Y, Z, whatever it can be. And their point or their element will be defined by the corresponding small letter, or we can define it by the omega as well, in as we do in our set. In the case of statistics, when we study statistics, at the place of A, we are very friendly to use the omega. Getting my point? And obviously the capital omega is denoting always the set. So yes, these are the things that will be there. Now, the second thing that we study is subset. What do you mean by subset? So, for a subset, what can we say? That if we have two sets, some sets will be smaller and some set will be bigger. But how can we know that? So it says, write it, subset. Let A and B are two non-empty sets. Let A and B are two non-empty sets. Then A is said to be the subset of set B. Then set A is said to be the subset of set B if each and every element of A, each and every element of the set A is also in set B, is also in set B. Set B. Here, put the star and write there. Here, set B is said to be, write it. Set B is said to be the superset of set A, and it is written A is the subset of B or B is the superset of A. This is, yes. Now, write next, proper subset. Let A and B be two non-empty sets. Non-empty sets. Then set A is called the proper subset of set B if all the elements of set A is also in set B. Also in set B. Write it. And at least one element in B which is not in A. Getting the point? So this line should be added, otherwise that will not be the definition of proper subset. So then this will be the proper subset. So A will be the proper subset of B, and we will write A is the proper subset of B, and we can say B is the proper superset of A. So yes, we can write this as well. Getting my point? Clear? Okay. Now, what next we have to study is the sub symbols that I will use frequently in our study, in our classes. So I will first write it down. Obviously, you can speak out the name. If you know the name well, that's good. If you don't know, obviously you have to write it down at your notebook. Getting my point? Okay. So the first is, I will say, speak it out. What's the name of this symbol? It should be implies. Getting my point? What is the name of this symbol? You can say if and only if, and I will say yes, that's it, that's correct. IFF if, or if and only if. You can say it, or you can say implies and implied by. So this is a both way symbols. I'm writing it here because I will use these symbols frequently. Next one that I am using is, yes, this. What do you say it? Epsilon. This is a small epsilon and one is capital epsilon. So yes, these are called epsilon. Epsilon. And the next symbol is ulta, yes, reversed E. This is called there exist. And one more is reverse epsilon. What do you say it? What do you say it? This is such that. Yes, these are some of the symbols that we use frequently. Sure. Yes, if you know it, that's well. Otherwise, you can write it down at your on your notebook. Okay. So coming to the next one. Next, we have to study some of the things of the set theory. I'm just recapping it. So equal sets. Right. If A and B are two non-empty sets, write it down. If A and B are two non-empty sets, if A and B are two non-empty sets, and A is the subset of B, A is the subset of B and B is the subset of A. A is the subset of B and B is the subset of A. That is, write it down. That is, if each and every element of A and B are, each and every element of A and B are same. Each and every element of A and B are same, then A and B are said to be, then A and B are said to be the equal sets. The equal sets. Now next one is universal set. One more set, I will write it here. Equivalence set. Write it down here. First equivalence set, then I will come to the universal set. So, your equivalence, what do you mean by equal and equivalence? What is the difference? I'm sure a lot of you know that what is meaning by equivalence set. Write it down here. Let A and B are two non-empty set. Let A and B are two non-empty set. Let A and B are two non-empty set. Then set A and set B are said to be the equivalent set. Are said to be the equivalent set. Are said to be the equivalent set if cardinality of A is equal to cardinality of B. It is written in both ways. Either you can write CA or CB, or you can write it in the absolute manner. So if the cardinality of A, it is read out as cardinality of B. Cardinality means the number of elements. Cardinality means the number of elements in the set B. Cardinality of B, we can write out it as this one. Getting my point? So yes, if cardinality of A is equal to the cardinality of B, then A and B are said to be the equivalence set. There is no issue. Okay. Now come to the next one. Universal set. In our case, universal set will be called the sample space. That I am making you aware of this. So in our case, in general, though first of all I will teach you about how set theory will go, but after that when we come to the probability theory, it will be called sample space. And when we say sample space, you must have in your mind the universal set. Getting my point? Obviously there we will discuss what do you mean by actually probability theory, what do you mean by random experiment. Those things I will obviously discuss, and in very good manner, very elegant manner, so don't worry about that. I know, because a lot of candidate whose language can be English only and who does not have good possession of any language in Hindi. Suppose in the North India, as I have seen, that a lot of good statistical institute are there. Obviously Kolkata is one of them, whose statistics is well cultured. So but obviously a lot of candidate who is from the other sides of the country, i I know, and a lot of candidates say me as well that, sir, there was not much facility to explore the statistics, and there was not good professors as well there. So yes, that is the issue with some of the universities. But don't worry, you came here, and believe me, you will be very joyous to learn statistics, not as a subject but as your life. So statistics, as I will teach you, though obviously it's complicated, there are some technical terminology where you can get bored of me, but then also I will say, I will must make it joyful. Don't worry. Otherwise I will tell some jokes as well. Don't worry, in the classes I will say some jokes as well. I will tell you the story, I will tell you the some of the motivational speeches. Don't worry about those things, I will be there. So yes. Now, so in any discussion on sets, we always have in our mind a master set from which all the sets are coming, like God. है ना, like gods, isn't it? So those master sets from which all other sets are coming will be called universal sets. In our example, we will call these sets as the sample space. I'm not defining it in more general way because no one is asking you that. Okay, obviously you know that this master set or universal set is also called, this universal set is also called a space, universal set or a space. I will not say sample space because sample space does have some meaning, but a space is a good word for it in general. So these will be the master sets. Now coming to the next point, we have to study about the Venn diagram in the set. So Venn diagram was introduced by a philosopher whose name is Venn. On his name, the Venn diagram name is created. So the philosopher name was Venn, and obviously he has created the Venn diagram. He has introduced the Venn diagram to the statistical or mathematical community. Actually, these are nothing but the geometrical interpretation, the geometrical representation of the sets as well. So suppose we are writing one as this, someone must have done it first time, na? We are writing two as this, someone must have done it once, na? So first time it was done, and obviously if it has been proven to the international community, to the mathematical community, to the statistical community, and if it was accepted by the researchers of the world, then it will come to the study. So these are the sets, and you know it well that in the Venn diagram, the bigger set, the universal set, is in general created by a rectangle, and then by an oval or by a circle we create another set which is smaller than and which lie in these universal sets or these space. So yes, this can be oval as well, and this can be, in general oval term is used, though that we have studied in our childhood, we were not using the oval term, we were using the circle term. So that's not the bad, I will not say you to leave that, though as you are now in MSc or some bigger state, so obviously you now need to change from the circle to the oval, your mindset should be changed. Getting the point? Okay, so these are the set, and obviously in this case you know it well that this inner set is called, suppose if this is the set A and this bigger set, if I say it B, then A will be the subset of B because all the parts of A is lying in set B, and that is the definition of subset. So A is the subset of B here, you can say. Now coming to the point, when we try to write the set, and we when you may have studied the set theory, there was a topic on the representation of set. So we in general represent a set in two ways. First one is tabular form, you know it well, and second is set builder form. What do you mean by tabular form? Representation, you can write it as representation of set, representation of set. First is tabular form. Suppose we have to write a set A is the set of X such that X belongs to natural number and X is greater than equal to 0, less than equal to 9. So this is the set builder form. Second is set builder form. So this is the set builder form, or you can say property form, because here what I am doing is, we have given a set name A, we are writing a general element x, a small x, and then we are writing the property of this x, that x is belonging to the natural number, set of natural number, and x is nothing but greater than equal to 0 and less than equal to 9. So we are explaining the property of this unique, this general element x, and that's why this is called property form of the representation of set A. Getting my point? Obviously it can be also be called set builder form or property form. Suppose I have to write this set A in tabular form, so it can be written as, suppose natural number, you know it, 1 2 3 4 5 6. So if I write it here 1 2 3 4 5 6 7 8 and 9, so obviously these also have the same property. These all are natural numbers, these all are greater than equal to 0 and less than equal to 9. So yes, this A set is nothing but this one. These two sets are same, but the method of representation are different in both the case. So have you got this point, what I am trying to tell you? Yes. So this is the case. That means in the first case we are explaining the property of a general element of the set, and in the second case, in the tabular form, we are listing out all the elements of the set. What we do, we are listing out all the elements of the set. So yes, that is the case here in the set. We have also to study some of the operations, but before that we will discuss about the concept of intervals. So let's come to the point. What do you mean by intervals? One question I'm asking you. Try to tell the answer, otherwise I will tell you. Is an interval a set? As till now, as you know, the candidate whose answer is yes are right. Yes, an interval is a set, and those sets are called continuous set as well. Getting my point? Because you know the substance, like if I want to suppose count the number of feet in a bowl, suppose feet in a bowl, then I can count it, no worry about that. But suppose if you want to count the water in a bowl, is it so? Does that not the substance? Obviously that is also a substance, as the wheat is substance, these are also substance. So both are sets, one is continuous set and one is discrete set, but both are sets. Now I'm not going deep into what sets are. These things, if I need to teach, it will be taught on the public platform. So if you want to see, you can see there. Yes. Now the next question is every set can be an interval? The answer will be no. Like the same, it cannot be, because suppose you are writing 1 2 3 4 5, how can this be converted into the interval? No, never, it can't be. This can't be the interval. But every interval is a set, because set does not mean 1 2 3 4 5 only, but the set is a bigger term than the interval. So yes, I'm defining here 4 types of interval that you already know. I'm just defining it here. Now, write it here. Write the concept of intervals. If, write it down, if omega is the set of real numbers, then the closed interval a to b is defined by a to b will be a set omega such that omega will be greater than equal to a and less than equal to b. An open set a to b will be defined by omega such that omega will be greater than a and less than b. A closed open set a to b will be defined by omega such that omega will be greater than equal to a and less than b. And an open closed set a to b will be defined by omega such that omega will be greater than a and less than equal to b. So these will be 4 intervals, 4 types of intervals that you study in more general case. Not more general case, these are the comprehensive, this is exhaustive cases. Getting my point? Okay. Now, one more question that is very interesting. Suppose I tell you, let me do some experiments. Suppose in our hand nothing is there, and I will tell you side, 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 side. It will fall down, it will fall down, it will fall down. Do you not laugh on me? Don't you laugh? Yes, you were laughing at this time. So what are you doing? If nothing is in my hand, why I'm saying side, side, side? Why am I saying this? Isn't it the boring thing? Isn't it the thing like, sir, you are making me foolish? No, that's not. Empty set is something like that. As you may have studied if you have gone through the movie Ramanujan. South Indian movie is, I think. If you have gone through that, you may know that this was the question asked by Ramanujan to his teacher. That, sir, if I divide 0 by 0, suppose I have 0 mangoes and I am going to divide it, distribute it to the 0 people, what will be the value? As you may be confused upon me, the teachers of Ramanujan were also confused, and he just scolded him and said that sit down. But that came to the concept of infinity, na? That came to the concept of indefinite terms, na? So there are some of the situations in the statistics and mathematics that is called indefinite situations where the answer got stuck and whose research is still being conducted at this time. In that particular situation, one is the empty set. As I have told na, that if I have nothing in my hand and I'm telling you side, 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 side. So what I'm telling you, I'm doing nothing. That is the main concept of what empty sets are. But yes, we have to study. Suppose I have this one and I am telling it, do it like me. Could you see your fingers? Could you see your fingers? If you are seeing, make it more sight. And are you now able to see your fingers? Because I am not able to see my fingers at this time. Now, say, do you think that this point where your fingers is at this time is infinity times far away, farthest away than your eyes? So the distance between your eye and your finger is infinity or not? You say, sir, no, sir. How can be it infinity? It can be 1 centimeter or 2 centimeter. How can it be infinity? Then why you are not able to see? Because sometimes you write it as, see here, this you write and say that, sir, these two, because these two are parallel, these two can never meet, and that's why I say, sir, this is infinity. Asymptotic result. This is the asymptote to the x-axis. You say it well. You know. This is the main concept of asymptote. This is the main concept of infinity. So yes, these are just the concepts. Next, we will discuss the concept of degenerate random variable as well. I'm not doing it at this time, but yes, I will do it in the probability theory and next to the random variable. Don't worry. But yes, write it down. Right? Putting the next point. When I say put the next point, say an arrow marks. Getting my point? When I say put the next point, this will be an arrow marks. That is, I say, according to me, it is a point. So write it down. For mathematical convenience, I am telling mathematical convenience. Yes. For mathematical convenience, we consider along with other sets, a set that consists of no element at all. No element at all. Now someone may say that if there is no element, how can I say that a set? But you need to know that vacuum is also a space. But in vacuum, nothing is there, na? Still, vacuum is a space. It has some significance. So yes, phi is also a set. Non-empty set is also a set. Sorry, empty set is also a set, and it has some significance. Don't worry, it has some significance, and that will work in future. Consist of no element at all. Full stop. This is called the empty set or vacuous set or null set. You can say whatever. Empty set, vacuous set, null set, void set. You can say it. Getting the point? It is denoted by phi. It is denoted by phi. Next point. For every set A, we have a result like phi is always the subset of each and every set. While for every element, for every element omega, we have omega does not belongs to phi. This is the result for the set phi, empty set phi. So write it down there. And then the next point will come to the operations on set. Operations, or you can say set operations directly. Set operations, like the operation of addition and multiplication, it is also there. We will do it for same as the operation of addition and multiplication is with the set of real number, you can say natural number or uh, integer. It is also the set operations, and we do it with the sets. So the first operation is union. Right in the point, right, by the union of two sets A and B, by the union of two sets A and B denoted by A union B, it is read out as A union B. By the union of two sets A and B denoted by A union B, we mean the set of all those elements, the set of all those elements of capital omega all those elements of capital omega which lie in at least one of them, which lie in at least one of them. So what is meant by this is, suppose this is set A and this is set B. What is meant by A union B is the set which consists of all the elements that will be in A and B. So getting the point? Yes, this will be the set. So the set A and B will be these shaded regions, A union B. Getting the point? Okay, next one. So let me define it in the notational manner. So A union B will be the set of omega such that omega either belongs to A and or either A and B, either A or B. So or omega belongs to B. Yes. So this will be A union B. Obviously this operation can be defined on different more than two sets as well, but I am defining it for the two, and obviously I suppose that you will do it for the next one, and if you do not understand, must let me know. Yes. So similarly for the more than two sets, Let me define it for you. Now come to the next. You will define it for the more than 2. I'm sure that you will define it for more than 2, and if you do not able to do this, then must let me know, must ask me in the live mentorship session. Take the live mentorship session as frequently as possible. Okay, now next point is intersection. I'm sure these are not the very complex topic, so I will come to the complex topic and then I will let you know everything about that. Write it down, make a point. By the intersection of two sets A and B, by the intersection of two sets A and B, denoted by A intersection B, denoted by A intersection B, we mean the set of all those elements of omega, the set of all those elements of omega which lie in both A and B, which lie in both A and B. That means A intersection B does mean that if A is this and B is this, so suppose this is A and this is B, then A intersection B will be this point. Yes, this one. So this will be A intersection B. Getting the point? Yes. So how can I define it? Define it as omega such that omega belongs to A and omega belongs to B. So there should be and. There should be and. Now, the next is there are two operations that we have defined. The third operation will be the difference and the fourth will be complement. You know it well, but I am just defining it here. Don't worry about. So come to the next point, the difference operation. Difference operation. Write it down here. Let we have two sets A and B. Let we have two sets A and B. A and B. Then by the difference of set A and B, by the difference of set A and B, that is denoted as A minus B, we mean the set of all those elements of A, the set of all those elements of A which is not in B, which is not in B. Let me show the Venn diagram for it. Suppose this is A and this is B. So obviously this is A, this is B. A minus B does mean that the set of all those elements of A which is not in B, because some of the elements are in B, but I am not considering those elements. I am considering those elements which is in A but not in B. So these parts, getting the point? Clear? Okay. So yes, this is nothing but A minus B. Clear? Okay. Now let me define it in a proper way. So A minus B will be, A minus B is defined as the set of all those elements omega such that omega should belongs to A and omega should not belongs to B. Yes. So A minus B is such element. Getting my point? Clear? Okay. Now, next to it, the next operation is complement of two sets. So write it down here, complement, and you know it very well, complement. We are just recapping these things. By the complement of set A, by the complement of set A, by the complement of set A, denoted as A complement or A dash, we mean the set of all elements of capital Omega universal set that do not belong to capital A. In symbols, A complement is the set of all those elements which is not in A. Getting the point? And we can say it, this is omega minus A. Yes. So this is the set of all those elements of capital Omega which is not in A. So this will be the case. And you can say it here as well. If you have written it down, we can what we can write it as A intersection B complement. It can be written. So B complement will be, leave this line and this, and then if we do the A complement, so this will be the case. So same place will be those. Getting the point? So we have studied union, intersection, difference and complement, and then we will come to the some of the rules and laws that is related to union, intersection and those complementation. So let's come to those points. Yes. So you know it well. I'm not doing anything more bigger. Obviously, this class is just the preliminary, very basic, zero level. This is zero level, and obviously today's class will be of zero level. But when we come to the next point, the next level, because in the starting, if I start teaching you very advanced things, it will go out of mind. So I will not do that. It should not be bounced by, it should be bounced back. Getting my point? So let's start. The first law is commutativity. You know it well, I know. Commutativity. How it is written? A union B can be written as A union sorry, B union A. So this is nothing but commutativity law, and same is the case for the intersection as well, because sorry, this is not intersection, this is union, and A intersection B should be equal to A B intersection A. Getting the point? Next is associativity. Associativity. I'm just writing it down here because it's too easy to do. A union B union C can be written as A union B union C, or we can write A intersection B intersection C can be written as A intersection B intersection C. This is the law of associativity. Next is law of distributivity. Distributivity. Distributivity, that means union is distributed over the intersection, and intersection can be distributed over the union. Distributivity. So this will be A union B intersection C can be written as A union B intersection A union C. Can we write it? Yes. And similarly for the case A intersects A union B intersection C, and I can write it for the next one A intersection B union C, and this can be written A intersection B union A intersection C. This is called distributivity principle. And the next one is idempotency. Idempotency, and it will be A union A equal to A, and A intersection A equal to A. This is called idempotency principle, idempotency law. So you may have written it, I'm just making it behind, just write it down. Once write it down, if you know it well, then also once write it down, it will not harm you, it's not the poison. So don't worry, you can write it down. Now next one point is De Morgan's law, and this is a very good law, very important law as well. De Morgan's law, and we will use all of the laws, don't worry. A union B complement can be written as A complement intersection B complement, and A intersection B का whole complement can be written A complement union B complement. And in more general case, what we can write is union of I equal to 1 to n AI whole complement can be written as intersection of I equal to 1 to n AI complement. And for the same can be applied for the intersection as well. So yes, intersection of I equal to 1 to n AI whole complement can be written as union of I equal to 1 to n AI single complement. So yes, these are the De Morgan's law, and you can have it well in your hand, because now in the next point that I'm going to teach you, set theory will go out, because that is also the set theory, but that you may not have studied till now. That is the advanced set theory, and you may have studied if you have gone through the lectures of BHU, I think. Yes, in BHU, that is in the syllabus, but still you may have understand or not, that I can't say. But today you will understand, and will understand surely, that I will say. So yes, I will try to make you understand those things. I will do it for the infinite set. Do you ever have learn about sequence of sets? You may have sometimes in BSc as well. So if I have the sequence of sets, what will be the final set? Understand that you are not understanding my thought. Let me come to this point. Suppose I'm starting with a set. Say this is set A. Suppose I am saying it A1, A2, A3, A4, A5. Getting these points? So these are the sets that I am making here. Now think of it. If I continue doing these things, if I am continue generating these sets, after a long time, after infinite times, which set will be generated? I will give you the practical example of this. Don't worry. So after a long time, a bigger set will be generated by following these rules that we have observed over in the starting time that we have observed. So how can I know these sets like the same as you all have faced the coronavirus case, and I know that every one of you have same feeling as I was in that time. a, a feeling of like what can we do, isn't it? No, but we haven't any idea what to do. Obviously our scientists, our medical practitioners have done something and have come out with the vaccines, and then we came out of our house. So how the behavior of those vaccine will be in the long run after 10 years, after 20 years, and after 30 years? How those practitioners, those researchers have elaborated these things? How? The answer of this question can be done only if you know the behavior of this set. So if you can find these sets, you can, if you have some theory that can be applied to find these sets, that theory can be applied for the next 10 years, next 20 years, next 30 years. Yes, that's it. Getting my point? Clearly getting my point? Okay. So yes, how these things will be helpful in your life in studying statistics, that according to me you have understood. So the sequence of, this is the sequence of sets, and this is the sequence of increasing sequence of set. Getting my point? So these sets are increasing, not uh, because yes, that can be decreasing as well, but here it is increasing. We can say non decreasing, and in general in the statistics terminology it is said, in a statistical terminology it is said that these sets are monotonically monotonically non decreasing. M and D, monotonically non decreasing, though we will make it let you write, don't worry about. So yes, I have made this. If I can do this with the shape as well, but I am not doing it because that will take time. You have understood it well now. That's it. I am for you. So let's write. Make the section heading, some results on sequence of sets. If someone of you are just have done just BSc or bachelor's, I'm sure that it will be something hard to you, not till this time, but in the coming time it will be hard for you to understand. But believe me, this you have to study in your MSc study and in your UPSC ISS exam. Though there will not be any question that will come directly from here, but these things, these words, these terminology I will use frequently at any work of a statistical phenomenon or a statistical concepts. Like in the statistical inference, when it comes to the completeness, you don't know about completeness, you know something, that what something is completeness, but how these can be dealt with, you don't. So that I have to do, that we have to do. Getting the point? Okay. Now, some results on sequence of sets. Let an, and if you haven't studied the sequence and series, I will must say you take a real analysis book, any book, NP Bali, Savita Arora, Malik and Arora. You can take any of the book on real analysis and go and must study that. Otherwise, I do not say that you cannot, but yes, there will be some problems that come to you, and it will be hard to find what I am telling you, because a lot of at a lot of place I will use the sequence and series concept. So it is a must, and it is not in your syllabus, because if you have gone through the syllabus and have analyzed it very well and have gone through the in-depth analysis, then the syllabus is up to the level of MSc. So I will teach you from the BSc to the MSc till the PhD, because some of the concepts will be beyond that also as well, so that it will be hard that you will not click a single question. Getting my point? Okay. So let an be a sequence, be a sequence of sets in omega. Omega is obviously the space or the universal set. We may consider, so suppose an is the sequence of sets like this one that we have created. So the sequence of set can be of this type, like increasing. So yes, that can be increasing, can be decreasing as well, na? Suppose I am doing it here. Suppose I am making some sets here. Like suppose I have made a bigger set here. Then I am making another set. Yes, this can be different second set, and I can make the third set as well. Clone it, make it short, and put it down here. Clone it, make it short, and put it down here. I can do this now. And suppose I'm again cloning it and making it very short. Can I do it now? Isn't it? So yes, if I am doing it, suppose this is our first set A1, this is our second set A2, this is our third set A3, and this is our fourth set A4, and similarly this is our nth set an. Suppose I am doing that, and obviously going through this manner, if I say you that as n tends to infinity, what will be the behavior of these sets? Like I'm telling you one a story. Yeah, in your family, and suppose I'm taking the example on me only, because I do not try to roast anyone. I am always trying to roast myself only. So let me tell you, I am your teacher here. I have some different characteristics. I am an administrator as well. In my office, I'm an administrator. So in that time, my behavior is different than what a teacher have. So if you come and work under me, you do not like me actually, because in that time I'm not a teacher. I can't behave like a teacher. I'm an administrator, so I have to make them work very good in a good manner. At my home, I'm a younger child, so I'm very cute guy then. Yes, that's the truth. Suppose I married and I go to my wife's house. In that case, what will be the case there? There, I will feel like king. Not this one, but that's reality is actually. So at different places, I have different characteristics to show. But the basic instinct that I have, like the morality, like the calmness, like the sense of humor that we may have, will always be there at every place. And it can be observed by a wise man always. If I am down to earth, that will always be there. Like suppose sometimes, as we have experimented it, suppose you are very angry, you are in very your mind is in troublesome, and you are riding your bike, or suppose car. So what in that case it's happening is, suppose someone come to you and do it uh, very in a haphazard manner, you got angry, but then also your basic instinct will not try to hurt him. This is what basic instinct says. So these basic instincts, what I say, is nothing but your long term property. What in the Indian system says sanskar. What it says in English, you may know. You can say it rituals, and you can say it morality. Yeah, I'm always saying it basic instinct that you may have. Sanskar does mean the basic instinct. In your term, I'm say personality. Yes, a lot of candidate is taking personality uh, development course, but I will say personality is what you are inside. So if you are inside, by inside you are a good guy, you will always be a good guy. There is no need to take any personality course. You just have to learn how to make these things better, and that can be done if you try to just observe yourself. So yes, these things will be there. Now, so obviously this can be inward and outward both ways. Getting my point? But someone may say, sir, why are you taking these two cases only? These are the sets, these are the sequence of sets. So I can take some haphazard sets as well, because if I know the manner of how these things is working, like how this is contracting and how these are expanding, it will be very easy to do how it will go long way. But in the time when it will not be easy for us to relate any pattern, to find any pattern there, like suppose sets are like this one, as this one, this one, this one, this one, this one. I'm just doing it by closing my eyes. So if, sir, if all the sequence of sets are like these, now tell me, sir, you are becoming very wise now. So now tell me, what will be the long time behavior of these sets, sequence of sets? Because these are also the sequence of sets as well. Yes, that can be, because when coronavirus came, to which people it will affect more and to which people it will affect less, it was not known to us. It was not, suppose someone say that what Ramdev, you know it well, the brand ambassador of Patanjali, Baba Ramdev, Yog Guru. He said that I haven't wear mask, I haven't stopped myself being social. Where is coronavirus? But that was not the criteria actually. They have been done, they have been closed in their house. But yes, once it was the statement of Baba Ramdev. If you don't know, you can search Baba Ramdev, you can see the picture of them. So this is the case. Obviously, there will be some rule that will make these sets long, that will find out the long term behavior of the sequence of these sets as well. Yes, and I will do that for you, don't worry, because in these two cases it was very easy to do. Yes, I will show how, but in the third one it was not as easy as it looks like. But then also I will do it for you. Write it down. We have considered three cases. We may consider, that's what I was writing, we may consider three cases. First is, the sequence is called monotone non-decreasing. 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 MND. Or we can say it expanding. So the first one type, expanding, if an is the subset of an plus 1. If an is the subset of an plus 1 for n equal to 1 to dash dash dash. Like, check it here. A1 is the subset of A2. So an is the subset of an plus 1. A2 is the subset of A3. A3 is the subset of A4. A4 is the subset of A5. And suppose it is an, then an is the subset of an plus 1, obviously. Getting the point? Getting the point? So yes. Now let me check here. What will be the union of A1 and A2? A1 union A2 will be A2. A1 and A3, A1, A2 and A3 will be A3. And in the similar case, if I say that I will take union of I equal to 1 to n AI, this will be obviously AN, the last set. The last set. So if I take the long term and n tends to infinity, it will be the union that will be the last set. Getting my point? So yes, that will be the last set. So write it down there, because I am trying to let you make notes. Since in this case, since in this case in this case union of k equal to 1 to n, ak is equal to an, is equal to an. Write it down there. Then I will write next. Limit n tends to infinity an, or the limiting set will be union of k equal to 1 to infinity ak. Getting the point? So long term means what will be the limit of that set. Getting the point? Okay. Now next point, this was the first set. Obviously in the second set, as I am making you understand, suppose here what will be the intersection of a1 and a2. Intersection of a1 and a2 will be, obviously this is a1 and this is a2, so this will be a2. And intersection of a1 a2 a3 will be a3, and these a3 are intersection, not union. So if you do these things for the n time, a1 intersection a2 intersection dash 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 intersection an, it will be an. And similarly if you do it for the infinite times, so it will be the limiting set. That will be the case in these two. The next one will come next, that I will discuss with you, don't worry. So write it down. The sequence is called monotone non-increasing or it may be called contracting, because the sets are being contracted, or contracting if an is the superset of an plus 1. In the previous case it was the subset, in this case it is the superset for n equal to 1 to dash dash dash. Since in this case intersection of k equal to 1 to n ak equal to an, we define limit an, or limit n tends to infinity an equal to intersection of k equal to 1 to infinity ak. So yes, these two are the results. And then I will come to the next, where we say it a general sequence, isn't it, no? Because these two were, the first one was expanding sequence or MND monotonic non-decreasing sequence. The second was non-increasing MNI monotonic non-increasing sequence, or we can say contracting sequence. But the third sequence that we have already seen, this sequence, and we say it general sequence. Getting the point? Okay. So the C is here. Write it down, and what we will do here is, first we will make sequence. In the first case we will make the sequence in the previous case as it was, so we will try to make it limit to be limited. We will develop some rule, some new sets on the basis of those sets, and then we'll discuss these things. So take this point as a point. Now for a general sequence, write it down and it will automatically be understood by you. Write it down. For a general sequence, I will make it the sequence contracting and expanding, and then we'll try to find some common points, some common base. First of all, write it down and you will understand it clearly at this time. For a general sequence, let us define supremum of k greater than equal to n, ak. This is equal to union of k equal to n to infinity ak, and infimum of k greater than equal to 1 n ak. This is nothing but intersection of k equal to 1 to infinity ak. So what it says that I am trying to tell you, come here at this page. Now see here, suppose in this set, some set I say a1, a2, a3, a4, a5, a infinity, and suppose from a10 to a infinity I am taking the union of a10 to a infinity, and say it a set b10. Can I say it now? So I am taking b10 equal to union of k equal to 10 to infinity a10. I can say it, sorry, ak. These are ak, and I am taking the union of k equal to 10 to infinity, and I am saying it b10. Similarly, I can define b11, b12, b13, and I am saying it the union set, sorry, supremum set, this b10, b11 something. Getting the point? We can do this now. Union, I can take the union of any of them. Yes, that can. Similarly, I can take the intersection of those also. Suppose I am taking intersection of k equal to 10 to infinity and b, suppose it is ak, and say it suppose ck. Getting the point? Sorry, c10, not ck. So this is c10. Are you looking into it? Now think of it. Which set will be bigger? Obviously union set, because in the union set, suppose this is a set and this is another set. So if I take this, the union of two sets, obviously the set will be this one. 1 second. Suppose then you will take these two sets as this one. But if you say the intersection, obviously the set will be this one only. So the union set will be bigger. That's why it is called supremum. Getting the point? And because these sets are intersections, so these are infimum, infimum, infimum. Getting the point? So yes, there will be two sets, and what I have told these sets as k equal to n to infinity, and so I will say it bn and cn. So what we have defined is, this is, I'm telling it bn and I'm telling it cn. Can I do it now? Okay, so write it down. If these if these are denoted by bn and cn, denoted by bn and cn, now we don't have to think of ak, we have to think of, because the mathematics has developed some theory, by the by applying that we will find the same base. If we find the limit for bn and cn, we will find the limit for an as well, that I will discuss right at this time. But first of all, if these are denoted by bn and cn, bn and cn respectively, then now let me check what is the characteristic of set bn, because bn will always also be a set, and what will be the characteristic of cn. So let me check here. I am writing it b1. So b1 will consist of union of k equal to 1 to infinity ak, and so it should be bigger set, most bigger. Now let me check it b2. It will be k equal to 2 to infinity ak, and in b2 there will be less amount of element, because the element that was in a1, that is now removed from here, from the b2. Getting my point? So yes, b2 is the subset of b1, then b3 is similarly the subset of b2, and in the same manner what we can say is bn is the superset of bn plus 1. That means bn plus 1 is the subset of bn. And so what we can say, as we have studied in two different cases, if bn is the superset of bn plus 1, bn will be called contracting set, contracting sequence of set, that we have told you at this time in two a and b points. It is the c point. Getting the point? So bn are contracting set, or we can say monotonically non-increasing set. So if we have to find the limit of bn, what will I do? What will I do? I will take the intersection of bn from n equal to 1 to infinity. Yes, that I will do here. So are you getting this point now? How I have made these bn contracting sequence? How I have proved? If you haven't, please repeat the video 2 to 3 times. Obviously you will get understood very easily. Now for the cn, I am telling here, for the cn as well, suppose I am taking here not cn, but I am taking here c1, and this will obviously be for k equal to 1 to infinity ak. This will be intersection. Now I am taking c2. This will be intersection of k equal to 1 to infinity, sorry, 2 to infinity and ak. And intersection means the restriction, na? Because the restriction of A1, commonness restriction there was that the element that was not in A1 should be removed from C1 but should be not be removed from C2. Getting my point? No, you are not getting my point. Suppose there is some point, I'm not taking a lot of points, I will take only 2 or 3 points because otherwise it will be huge. Suppose this is A1, A2, A3. What will be its intersection point? Its intersection point will be this. Oh, sorry. So yes, this will be intersection point. Now, suppose I have to see the intersection point of only 2. I have to see the intersection point of A1 and A2. Then this will be bigger set. So which set is bigger? A1 intersection A2 intersection A3 or A1 intersection A2? Obviously A1 intersection A2. Getting the point now? So C1 have more set to be intersected, C2 have one less set to be intersected, and C3 have some another less intersection there. So in that case, C1 will be subset of C2, will be subset of C3, and so here Cn is the subset of Cn plus 1, and this was the case in MND set, monotonically non-decreasing sets, sequence of sets, or you can say expanding sequence. So the sequence are being expanded here, and that's why if we do union of these sets, these Cn, if you do union of this Cn, then we will get the limiting set of Cn, sequence of Cn. Getting my point very easily? I'm trying to let you understand these things, because if you do not understand at this time, though obviously you can come to me, but if you haven't understand at this time, I don't think that anyone can let you understand. Yes, because this is in as easy language as possible, I have done it. Now, so what I can do is limit Cn is equal to union of n equal to 1 to infinity Cn, and limit Bn will be intersection of n equal to 1 to infinity Bn. But Bn is not just a set, it's a set made by us. So we can write at the place of Cn union of n equal to 1 to infinity and intersection of k equal to n to infinity ak. And for the Bn as well, we can write n equal to 1 to infinity union of k equal to n to infinity ak. Can we write it? Yes, we can, and there is no issue in that, na? Yes. So now write it here. These two sets, write it down. These two sets, what we got here, the limiting Bn and limit Cn, these two sets, lim Bn and lim Cn, are called respectively the limit superior and limit inferior. The limit superior and, sorry, we have to do it in a different way because we have written here differently. Limit inferior and limit superior. Limit inferior, infimum will give us inferior, limit inferior, and supremum will give us limit superior. Limit superior. Getting the point? So yes, these two are called limit inferior and limit superior. This is denoted as limit, and by the recurring line below the limit, and limit superior, limit, and recurring above the limit, lim. So yes, these two are the points. So now coming to the next, if you have written, I'm coming next. Okay, now obviously, write it down. Obviously, limit superior an is the set of all those elements of omega of omega which belongs to an for infinitely many n's. These are the terminology that is used. Infinitely many n. While limit inferior an is the set of all those elements of omega which belongs to an for all but a finite number of an. Now what a rule says, what does it mean is that if you think of the limiting property of the supremum set, that means limit bn, which is limit inferior an, which is also called limit inferior an, limit superior an, is nothing but the set of all those sets which have infinitely many points in more general case. And the second one was limit inferior, which will be some small point because we are taking intersections, so we will get a small points there. So that's why it is the finite number of an. Getting my point? Okay. Now what does the rule say? The rule says let limit inferior an is equal to limit superior an. if this happens and suppose this is equal to a, say it a, then the limit of an, then the limit of an, sequence an, the general sequence an is said to exist. Otherwise limit does not exist. Exist, said to exist, and a is called the limit of, a is called the limit of an, sequence an. So yes, then in that case this a, common a, is the limit of an. Getting the point? I thought that you have understood it very well. I wish. Otherwise, if you do not have understood, must come to me. Let me know what you have not understood. And if anything comes to your mind, must let me know. Must take the advantage of live mentorship session that is handy to you. And obviously, it will work out. So, this was the session of today. In the next session, we will discuss some more advantageous things in the measure theory, because the first two sessions will be of measure theory. I hope you may have enjoyed this session, and if not, you'll enjoy next. So obviously there will be some toughest things as well, though I have to teach you those things as well. That's why you came here, because easy things can be learned from anywhere, but the toughest things that no one will teach you, but I will teach you those things as well. So for today, that's all. We will meet in next class. Thank you.